Hello viewers, welcome to Brilliant Online Academy. Your tutor for today will be Teacher Shaban Obuya, and I'm going to take you through limits of a function. But before we continue, please let's subscribe to our channel, like, and if you have any question you can also share it on the comment section. Now, you can also click the notification button so that whenever we upload any video, YouTube will automatically notify you and you will be able to work with us so that we may save on the same channel. So if it comes to limit of a function, I'm going to introduce some of the questions that the students think are very difficult, but they are much simpler if you know how to approach them. Before we go to the examples that will direct us on how to evaluate limits, I want us to have some basics on the evaluation of limits. And if you might be asked, what is this that we say limit? What is this limit? So the simplest definition of limit is just a number to which a function approaches. Limit is a number that a function approaches. So for example, if you're given the limit as x approaches 2 of 3 or of x, yes, so this will be the same as 2. Why? Because our limit tends to 2, x tends to 2, so that will be 2. Now, from that brief introduction, I want us also to discuss some of the methods that can be used to evaluate limits. So in evaluation of limits, 4 methods apply. One of the methods is direct substitution. We can use direct substitution. We can also use factorization. We can also use rationalization, and finally we can also use Hopital'S rule. Now, so we can apply the 4 rules while evaluating limit of a function in differential calculus. So let's go directly to our examples that is going to give us a clue on how to evaluate these limits using the 4 principles. Now, our first equation, you might be asked to evaluate the limit. Evaluate the following limits. So our first limit will be limit as h tends to 0 of square root of h plus 25 then minus 5 over h. So if you're given a question like this, what are you supposed to do? 1, let's check. If we use direct substitution, are we able to evaluate the limit? Then you will realize that if you introduce 0 where h is, then all of this function will be undefined. Therefore, knowing that the function is undefined, we cannot use direct substitution to evaluate the limit, or rather, we go to another method. And the other method that we can apply here is we can use rationalization method to evaluate the limit. And for us to apply the rationalization method here, it means we find the conjugate of the numerator. Then we multiply everything, both the numerator and the denominator, by the conjugate. So this will be simply multiplied by the square root of h plus 25 plus 5. Then you also multiply the denominator by the square root of h plus 25, then plus 5. Now, after you're given this question, or after writing this step, we are going to multiply both the numerator and the conjugate. And if we multiply this, it simply means you square this, then minus 5 squared. So that will simply limit as h tends to 0 of square root of h plus 25 squared and minus 5 squared. So you can also prove that by multiplying directly and see if it will bring you this. The denominator will be h multiplied by square root of h plus 25 plus 5. Now, let us go and square this. So you realize that this square will go with this square root. So we will have the limit as limit as h tends to 0 of h plus 25, then minus 25 over h into square root of h plus 25 plus 5. Now in this, you will realize that in the numerator, plus 25 will cancel minus 25. So we will have h itself on the numerator. So this will be the same as limit as h tends to 0 of h divided by h square root of h plus 25 then plus 5. Everything under that. Now, if you look at this function now, it is automatic that h will cancel h. So here will remain with 1. So this can also be rewritten as, that can also be rewritten as the limit as h tends to 0 of 1 over square root of h plus 25 then plus 5. Now, if we introduce h be equals to 0 to the equation, we realize that it will not affect the function. So, direct substitution applies. That will be limit as h tends to 0 of 1 over square root of 0 plus 25 plus 5. And 0 plus 25 is just the same as 25. So we have limit as h tends to 0 be equals to 1 over square root of 25 plus 5. So this is the same as limit as h tends to 0 will be equals to 1 over 5 plus 5, which is equals to 1 over 10. So our limit for that function becomes 1 over 10, and you will be done. Just as simple as such. So, guys, kindly continue subscribing to our channel, and you will learn more about these things. They are very simple in approach. Let's also have another example to give us a leeway on how these limits can be evaluated. What if we ask to evaluate this, our second limit to be limit as x tends to 3 of x cubed minus 27 over x squared minus 9. Now in this question, you will realize that if we use direct substitution, that is, when we substitute 3 on the numerator, we'll automatically have 0. We'll automatically have 0. But that should not be the case. If we have 0, then it means the limit will be undefined. And once the limit is undefined, then we are not able to obtain or to evaluate the limit of this. What do we do? We are going to factor out the numerator and the denominator. Then we see the parts that cancels each other. Now, if you factor out this, we are going to factor out this in the form of a minus b into a squared plus 2ab plus b squared. Then this will be in the form of a minus b into a plus b. So let's factor out our numerator. For us to factor out this, we have the limit as x tends to 3 of x minus 3 into x squared plus 3x plus 3 squared is 9. So you can confirm, if you open this bracket, if it will bring us back to this. Then divide by, if we factor this in this form, it will be x minus 3 into x plus 3. Now, from this, you realize that x minus 3 cancels x minus 3. So we have limit as x tends to 3 of x squared plus 3x plus 9 over x plus 3. Then we again try if direct substitution can help us here. So if direct substitution can help us here, then it means that we can apply that to obtain or to evaluate the limit of as x tends to 3. So it will be limit as x tends to 3 equals to 3 squared plus 3 times 3 plus 9 divided by 3 plus 3. So that will be the same as limit as x tends to 3 of 9 plus 9 plus 9 plus 9 plus 9 over 3 plus 3, which is 6. So this is the same as limit as x tends to 3 will be 27 divided by 6. And this is the same as 2 goes here, 3, not 2 but 3, 3 goes here 2 times, 3 goes here 9 times. So this will be the same as 4.5. So our limit as x tends to 3 for this function will be equals to 4.5. And you shall be able to evaluate the limit. That's how simple it is. I hope you enjoy learning with us. Okay, let's give an example. Now that we've discussed one example on how to apply direct substitution and also factorization, I want us to, and we've also discussed on the rationalization, I want us now to see how to apply Hopital'S rule. Hopital'S rule in evaluating the limits. Now, in Hopital'S rule, it is used for indeterminate cases. It is used for indeterminate cases where the function of x or g of x both approaches 0, positive infinity or negative infinity. For example, let's have this example. So if we are given a limit as x tends to positive infinity of 3x squared plus 5x minus 8 over 7x squared minus 2x plus 1. Now, in this example, you will realize that our limit value of x tends to infinity. And if we replace this directly here, infinity over infinity will be undefined. So, we are not able to define that. So what should we do? In this case, if this is the case and we are not able to factorize or rationalize, what do? We get the derivative. We differentiate the numerator with respect to the denominator. You differentiate up to a time whereby we are able to eliminate this infinity. So this will be the same as limit as x tends to infinity. The first derivative for the numerator will be 6x plus 5, then over first derivative will be 14x minus 2. This is our first derivative. Now, after differentiating this and this, you will realize that we still have x in our equation. And if we reintroduce the infinity part here, we will still have infinity over infinity. And that will not be defined. What do? We differentiate the equations for the second time. That is, we find the second derivative. So it will be limit as x tends to positive infinity should give us, if we differentiate that, will be 6 over 14. So once we have 6 over 14, this will be 3. 2 goes here 3 times, 2 goes here 7 times. So our limit will becomes 3 over 7. If we evaluate the limit of this. So, guys, this is how simple it is. If we continue, if you have any question, kindly submit it to our office on the comment section. We'll be able to guide you appropriately. All the best.